Hello, and a very warm welcome to the Data Scientist course. To many people, data science and machine learning feel like unknown territory, something too abstract and complex. To show you that isn't the case, I would like to start by giving you a hands-on example of what to expect from this course and what you will be able to do on your own only a few hours into our training. There are three keywords that will come up a lot during the lecture: data, algorithm, and insight. Here, we have data collected from the customers of a shop, 30 observations in total. Each observation represents a client who shared their customer satisfaction and brand loyalty. Let's suppose the owners of the shop hired our consultancy firm to analyze customer behavior. Dividing the shop's customer base into groups of individuals with similar traits is a great way to reduce complexity and come up with ideas on how to serve these customer groups better and, of course, win their business in the long run. To do that, we will have to apply machine learning. Ready? Here we go. The data set that we've got is an example of a scatter plot. How many groups of points can you hear? There are two groups stand out. In data science, we normally clusters, so two clusters can be identified instantly with no machine learning whatsoever. One represents people with low loyalty and low satisfaction, containing all the rest. Our preliminary visual examination shows us that there are some insights we can draw for sure, but let's take a more scientific approach. Most of the times, in data science, you would want to standardize data. Next, we unsupervised machine learning. Typically, means algorithm. We will for the code, which we will examine later on in the course, looks like the thing. And we are done. I can now plot the data using the vectors of the new scatter plot. We've got the same scatter for clusters. Our custom segment. From here, we can the ones with low satisfaction will be called alienated. Those with high satisfaction and those with low high loyalty are supporters. And the more disloyal but have a high satisfaction, these are roamers. Just a few lines of code, we've reached a remarkable result. We have segmented our four different groups. We've applied an algorithm on our data to reach insight. Naturally, we must analyze what we see. Data science is about making sense of numbers. We have four groups, but only one of them is favorable. Cluster analysis indicates the problem. Some clusters are data, others are disloyal. However, we must figure out how to solve the problems. What are some ideas a data scientist and management will come up with? It makes sense to focus our efforts to turn supporters into fans by improving their shopping experience. Normally, we would have to dig deeper to find the drivers of dissatisfaction in these customers. Maybe it is long queues, or unfriendly staff, or perhaps high price. Whatever the reason, we must take actionable steps to fix the issue and make our support here. Simultaneously, we can do something else. We turn into fans by increasing their brand loyalty. Look cards, personalized discounts, vouchers, and raffles are different strategies used to make client long run. Great. Please bear in mind that exercise steps along typing code step by step, a heat map, and finding the optimal number of clusters. However, these are all topics we will address later on in the course. So, let's begin acquiring knowledge needed step by step until we are insights from larger data sets with various algorithms so turn all data into actionable insights. The Data Scientist course is an amazing journey, and we are thrilled to have you on board. This is the first attempt, to the best of our knowledge, at creating a program starting from the very basics. It will teach you the foundations of mathematics and statistics, and then gradually continue with advanced statistical analysis and machine learning in Python. Before we dive into content, I would like to share a few words about me and Ilya, who co-authored this course. I am Martin, and I love the fact that I have been a Udemy teacher for 2 years now. My core areas of expertise are business intelligence, Python, and SQL programming. I love interacting with students, and it truly makes my day when I see that I have received a 5-star review from a happy student. My colleague Ilya is a mathematical whiz kid, and he loves teaching machine and deep learning. His quantitative background and ability to break complex topics into digestible bits make him the perfect teacher for the statistical and machine learning parts of our course. I'm happy we worked together on this project, as this is something we wanted to do ever since we met at university. The Data Scientist program is truly comprehensive. Here's how it is structured. We start with an intro where we will discuss the world of data science. We explain why data science is important and how it helps businesses stay competitive in this day and age. Then, our training continues by introducing important mathematical and statistical concepts that are essential to do data science. Once we have laid out a solid foundation, you will be ready to learn Python programming. Starting from the very basics, we will build up your skills, and soon you will be able to solve advanced statistics tasks such as clustering, factoring, and carry out different types of regression analysis in Python. Of course, we saved the best for last: building machine and deep learning algorithms. Image recognition, client segmentation, sales forecasting. Our machine learning training is complete and fully real-life oriented. Leveraging Google's state-of-the-art TensorFlow framework, you will be able to build ML algorithms like a pro. To get the most out of this journey, please don't skip any lectures, as we will gradually build on your knowledge. It is essential that you start at the beginning, as that you will lay the foundation you need to tackle the more advanced topics you will find later on in the program. Many of our lessons contain downloadable resources that will help you reinforce what you have learned. Course notes, exercise files, PDF materials, handy notebook files, everything is included and can be downloaded easily. I strongly suggest you complete all the exercises, as they are designed not only for practice, but also an additional source of information that will enhance your data science solving skills. Those of you who complete 50% of the course will receive a gift from us: our private Tableau training. Please a secret link to the Tableau course. Moreover, feel free to experience difficulties, would like to ask a question, or simply the community. We're always happy to hear from you. I hope you are as excited as I am. Straight in and begin this journey together.
What's so important about data? In this day and age, maintaining a healthy business goes hand in hand alongside working with data. Whether you understand it or not, there is no denying that data is at the foundation of any successful company, and the business entrepreneurs that are leading the way are aware that looking deeper into data is what will make them tower above the competition. Let's start with the data team, the big data team. They will want to solve a business problem. The team will do a significant amount of work on the data that is available first. Based on that, the business intelligence team will provide a business insights dashboard. After the dashboard is ready, the data science team will use some business analytics or data analytics tools to develop models that could predict future outcomes. Hold the phone! What on earth are we talking about? Unless you are a data science whiz kid, you may think we're just picking words out of the dictionary and sticking them together at random. Nope. These are actual data science buzzwords, and not only that, there are many other similar phrases. No wonder you're confused. But fret not. It's completely understandable for you to feel like this. let us shed some light as to how things became so complicated. One cause of this confusion is the constant evolution of the data science industry, and in turn, the meaning of these buzzwords. This complicates the situation a lot. For example, someone who had the title of statistician 25 years ago would have been responsible for gathering and cleaning data sets and applying various statistical methods to the data. After some years, however, with the growth of data and the radical improvement of technology, this statistician would now be required to extract patterns from data. Henceforth, a new buzzword was coined: data mining. Similarly, forward wind a few more years, and the same statistician, due to new mathematical and statistical models, could now perform more accurate forecasts. And again, another term has found its way into an already inflated business glossary: predictive analytics. Has the statistician changed her job by this point? Nope. Are her goals different? Nope, not really. However, she is more qualified now to be part of the statistics department, predictive analytics team, or have the title data scientist. Hopefully, it's easy to see now how these buzzwords develop over time and how someone who would qualify as a statistician 25 years ago, kept up with modern technologies, could fit into a multitude of professional categories now. Interesting, but a little messy, right? Another cause of confusion, which stems from the one just mentioned, comes from HR managers who, understandably, can become overwhelmed with the barrage of new terms and buzzwords flying around. This causes them to label job positions inaccurately, often seeming like they are choosing them on a whim. One HR representative may call a job position data analytics specialist when, in fact, they need a data analyst. Another may employ a junior data scientist when they require a business intelligence analyst. Of course, there are many companies that word their job offers brilliantly, but this is not standard across the board, which can cause even more of a mess. Now, as exemplified already, the world of data and data science can seem overwhelming and may very well make you want to run away and hide from anything data related. But bear with us a little longer. We, the 365 Data Science team, are here to help you sort through the clutter and see data science in a whole new, brighter, clearer light. We have designed a unique infographic to put everything together. Of course, you could search the internet for different glossaries, but why waste time? With us, you will find an aggregated, concise, and to-the-point structure containing all technical and business terms that are frequently used in the field of data science. We begin by clarifying the similarities and differences between the terms business analytics, data science, business intelligence, and machine learning. Then, we focus on helping you digest the definitions you need to know in an effective way. By the end, you will be more than capable of being able to relate and apply various expressions and buzzwords to the areas of data science they belong to. So, what are we waiting for? Okay, so it's time for us to create a diagram that will shed light on the most popular disciplines in the data science field and how they all intertwine with each other. As you know, everything is not particularly clear-cut, but the following diagram will help untangle the knotty mess of activities in the data science and business realms. Hold on to your hats. Let's begin with a list of terms covering a few aspects of the business sphere. Business case studies, qualitative analytics, post-haste. First, and copy all the business world. Builds with a rectangle here. Good. Following. How many of these terms involve working with data? Another rectangle and activities for which it is available. The ones, if any, would this rectangle? There is some. That's because some business activities are data are subjective or experience-driven. Of course, there are disciplines that will overlap. We will place them in a common area of the rectangles. So let's see. Which of the subfields from our list represents data? Well, you'll need data to create a preliminary report. A visual representation of the form of your company for last year's dashboard. And also a forecast for the future sales of your company. Sit comfortably in the overlapping area. Great. There are two terms, business case study and analytics, as they belong only to the sphere. They're not related to work with data. Let's explore why. Business case studies are real-world experiences of how business people and companies succeed or fail. You don't need a data set to learn from business cases. Thus, purely rectangle. Or qualitative analytics. As touched upon in the previous video, this is all about using your initial knowledge of the market to help in the thinking process. Perfect. Things are becoming clearer already. Now be the big time to say love. The reason for doing that is that some of them refer to activities that explain past behavior. Others refer to activities used for predicting future behavior. Let's cut the picture roughly. This line present. All terms that are on the right side of this line, future planning, and forecast line, will be related to the analysis path of events or data. Business studies examine events that have already happened. One could learn from them and attempt to prevent making a similar mistake in the future, right? As a result, I would say studying business cases is hard. So, this activity refers to the past. Hence, must be a little of the vertical line on our graph slightly to be a contrast to the business term, qualitative analytics. This includes your behavior, therefore, must be placed on the right. So, in essence, what we have now is qualitative analytics, which areas, while learning from business case studies is part of your business analysis. However, this is not what many professionals say. In practice, analytics is comprising both analysis and analytics. Although this goes against what I said earlier, please allow us to accept the industry jargon and leave business analytics labeled in business processes. May look we're confusing match, but things will be simpler in the long run. All right. Or many of these terms and where they fit with each other. What about on the diagram? Well, preparing a report or a dashboard is always a collection of past data, so these terms will remain unchanged. Forecasting, though, is a future-oriented activity, so we can move it to the right of the black line. It must still belong on the business. It must be in the area business analytics and data intersect. Great! Again, it's common practice to use the encompassing term data analytics both and analytics. While we know what terms mean now, to keep things simple, follow this under other business professionals. Good idea. Okay, good. Let's continue adding another term. Data science. Data science is a discipline reliant on data availability. Business analytics does not rely on data. However, data science incorporates part of data analytics, mostly the part that uses complex mathematical and programming tools. Consequently, this green rectangle represents time with data analytics, but beyond the area of business analytics. Okay. Does this mean that the preliminary data report, or visuals creating dashboards, and sales forecasting are of interest to a data scientist? Absolutely. And now, do you think we can find an example of a science and is considered data analytics? But analytics? Well, the oil and gas industry and the optimization of drilling operations. This is a perfect subarea. Data science can be used to improve the accuracy of predictions based on data. Activities typical for drilling efficiency, and that certainly It's busy. Great. What is left is to think of analytics, but neither data science nor analytics. Here as well. Digital signal processing is used to represent data in the form of discrete value, which is an example of numeric data. Therefore, data analytics can be applied to digital signal in order to produce a higher quality signal, and that's what digital signal processing is all about. Amazing! We hope the diagram is helping you to visualize how together, because we're not done yet. We will continue with the related to the science in our next video. See you there.
Now that we've seen the different types of data and levels of measurement we can have, we are ready to explore graphs and tables, which will allow us to visually represent the data we are working with. Visualizing data is the most intuitive way to interpret it, so it's an invaluable skill. It is much easier to visualize data if you know its type and measurement level. As you may recall, there are two types of variables, categorical and numerical. In this video, we will focus on categorical variables. Some of the most common ways to visualize them are frequency distribution tables, bar charts, pie charts, and Pareto diagrams. First, let's see what a frequency distribution table looks like. It has two columns, the category itself and the corresponding frequency. Imagine you own a car shop and you sell only German cars. The table below shows the categories of cars: Audi, BMW, and Mercedes, and their frequency, or in plain English, the number of units sold. By organizing your data in this way, you can compare the different brands and see that Audi has been sold the most. So, that is a frequency distribution table. However, tables aren't much fun, are they? Using the same table, we can construct a bar chart, also known as column chart. The vertical axis shows the number of units sold, while each bar represents a different category indicated on the horizontal axis. In this way, it's much clearer that Audi is the best-selling brand. Okay, let's represent the same data as a pie chart. In order to build one, we need to calculate what percentage of the total each brand represents. In statistics, this is known as relative frequency. Naturally, all relative frequencies add up to 100%. Pie charts are especially useful when we want to not only compare items among each other, but also see their share of the total. Okay, this example could be easily transformed into a business example of market share. Market share is so predominantly represented by pie charts that if you search for market share in Google Images, you would only get pie charts. Imagine that the data in our table is representing the sales of Audi, BMW, and Mercedes in a single German city, say Bonn. The chart will show us the market share that each of these brands has. Lastly, we have the Pareto diagram. In fact, a Pareto diagram is nothing more than a special type of bar chart where categories are shown in descending order of frequency. By frequency, statisticians mean the number of occurrences of each item. As we saw earlier, in our example, that's exactly the number of units sold. Let's go back to our frequency distribution table and order the brands by frequency. Now, we create the bar chart based on the reordered table, and voila! We almost have a Pareto diagram. There is one last touch to make it one, a curve on the same graph, showing the cumulative frequency. The cumulative frequency is the sum of the relative frequencies. It starts as the frequency of the first brand, and then we add the second, the third, and so on, until it finishes at 100%. This polygonal line is measured by a different vertical axis on the right of the graph. At each of its vertices, it shows the subtotal of the categories to its left. See how the Pareto diagram combines the strong sides of the bar and the pie chart? It is easy to compare the data both between categories and as a part of the total. Furthermore, if this was a market share graph, you could easily see the market share of the top 2 or top 5 companies. Finally, it is named after Vilfredo Pareto. You may have another idea of his, the Pareto principle, also known as the 80-20 rule. It states that 80% of the effects come from 20% of the causes. A real-life example is a stint by Microsoft that by fixing 20% of its software bugs, they managed to solve 80% of problems customers experience. A Pareto diagram can reveal information like that. It is designed to show how the best data. Okay, these are the main ways in which we can visually represent categorical data. In our next lecture, we will get acquainted with the most graphs for numerical data. Thanks for watching. Finally, it's time for the practical example we've been talking about. In this lesson, we will see an actual database of a real estate company operating in California. All right, we are interested in the statistical properties of the data. That is why we have reordered the database and cherry-picked variables and then imported these in a spreadsheet. The labels of the columns have been made friendly even for those of you who do not have any experience with real estate. Finally, we have altered the names of the customers for confidentiality reasons. Okay, the company is launching a marketing campaign, but it wants to target its audience properly. The management suspects that after some short analysis, marketing results can be improved without the need of investing additional resources. We are the data analysts who are going to crunch some numbers and identify which groups of people are most likely to buy our product. Once we have done so, we will instruct the marketing team to focus its efforts on these groups. The first thing we have to do when we analyze the data is to get acquainted with the table. It illustrates the sales of real estate property for a specific company. Let's call it 365 Data Science Real Estate California. Hopefully, nobody else thought of that name. Second, the table has 2 parts, left and right. On the left-hand side, we have product information. On the right-hand side, we have customer information. You can easily spot that all products are listed, but customer information is only available for some products. This is because we input information about a customer once the deal is done. Logically, only sold items are associated with a buyer. Let's see what a row looks like. This should clear up the logic of the table for you. Nora Lynch, with customer ID C0004, was 56 years old when she bought apartment 43 in Building 1 in order to live there. She paid $377,313 for an area of 1,160 square feet in June 2004. Nora is from California, felt very satisfied with the deal, and did not get a mortgage for the purchase. She found out about our product through our website. Okay, now that that's out of the way, we need to dig a bit deeper into these variables. We will identify types of data and levels of measurement for some of them. This is a crucial step, as we cannot analyze the data if we don't understand its type. Let's start from the first column, ID. ID is the value that we assign to each item which lets us differentiate between products. It may look numerical to you, but in fact, it is categorical. That's very counterintuitive the first time, so let's clarify it a bit. What if we use names like John, John 2, John 3, and so on until John N? The meaning would not change. ID variables are like names that we assign to different products. However, it is much easier to use numbers as unlike names, we have an infinite number of numbers. A simple way to check if a variable is numerical or categorical is to interpret its mean. Think about it. The mean ID number shows nothing. Now, oppose this to the mean price, for example. It is clear that the mean price is a very valuable piece of information. Okay, the bottom line is that ID is a categorical variable. What about its level of measurement? Well, it is qualitative, nominal. Clear? Clear. The next variable we'll have to examine is age. Age is rather interesting. The level of measurement is quantitative, ratio. A rule that is used for verifying ratios is asking the question, is there a true 0 point? Well, for age, it is obvious that when you were born, you are exactly 0 years old. That's the true 0 point. So, we are safe. However, what's truly intriguing is whether age is discrete or continuous. In fact, it may be both. In this case, we can only see age as a whole number. Therefore, it is discrete. However, similar to weight, a variable we discussed earlier in the course, age is a continuous variable. At the time I am recording this, the Statue of Liberty is 131 years old. But I may get more specific by saying it's 131 years and 11 months old, or its age is 131.92. If I add days, minutes, and seconds, you get the point. When you are dealing with age, you decide its type, depending on your work at hand. The next variable we have is age interval. This is yet another way to represent age. Once again, it is either continuous or discrete, as we are talking about the same variable. This time, though, the level of measurement is an ordinal instead of a ratio. The age groups represent different categories that are ordered but are not numerical. This serves to show that the same variable can have different levels of measurement within the same database. All right, let's move on. In most corporate analyses, price is central. No matter the dataset, it is always a numerical variable that, like age, may be discrete or continuous depending on your needs. If you are interested, banks and corporations treat it as continuous, and so will we. The level of measurement here is ratio. The next variable we want to look into is gender. It is of categorical type, and its level of measurement is nominal. It is very similar to yes and no questions that we discussed in previous lessons. Such variables are called binary, as there are only two possibilities, which are always categorical. Finally, let's check out the location. We will discuss state in more detail and leave country for homework. The variable refers to sales in the USA only. Note that only if the country put as USA, we would have a value for state. State is a categorical variable like ID that we talked about earlier. In fact, you can label the US states from 1 to 50 and use numbers instead. Either way, the variable is categorical and its level of measurement is nominal. Okay, excellent. We've categorized the variables we are going to use in this video. This spreadsheet is available for you in the resources section. Together with the exercises we've prepared on this dataset, you can practice the entire section about statistics. All right, back to our problem at hand. We have to identify the groups of people who buy the most of our product. Let's start with gender. Before we get the data, we have to create the frequency distribution table. In the course notes, you can see how that's done in Excel. However, in this video, I'll skip this step and get to the frequency distribution table. Now, we have three possibilities for gender: male, female, or a cell where gender is not available. Since some properties were purchased by companies, they have no gender. Nevertheless, we have to include them in the analysis or explain why we omitted it in the report. Gender is categorical. We said that a good way to represent it in practice is with a pie chart. Okay, we can clearly see that most clients are male. However, this information is biased, as the customers in this database are the people who signed the contract. It is very likely that a family bought the apartment, but our data shows us only the person who signed the contract. Such variables are interesting to see, but it is not a good idea to include them in the data-driven decisions we make. Okay, let's carry on location. What chart would be useful to show this? State is a categorical variable. We may use a bar chart or a pie chart. However, I prefer the Pareto diagram as it gives additional information. From the graph, you can immediately see that the majority of clients are from California. A possible scenario is to decide to invest in marketing for the top 75% of the locations. This will mean that we can focus on California and Nevada alone. Next, we want to see age. First, we have to note that age represents the age of the buyer when the deal was sealed. The formula used is the year of the deal minus the year of birth of the buyer. We are doing this because we want to see the age at which customers buy our product. Their current age is irrelevant. Moreover, real estate is something people rarely buy more than once in their life, so we expect age to be a central variable in our analysis. Let's first plot the frequency distribution of age. This is done by creating a histogram with an interval length of 1. Now we can move on to the age interval representation. The options there are 18 to 25, 26 to 35, 36 to 45, 56 to 65, and 65 plus. Most of the data falls between 25 and 60 years, which is evident from the frequency distribution graph. Therefore, our intervals are a good fit of the data. Let's build a new histogram based on them. Done. This representation is neater, isn't it? We can clearly see that 36 to 45 is the age at which most people purchase a real estate property. Moreover, it is evident that customers from 26 to 65 years old account for 87% of our observations. But we are better than this. We can calculate more statistics to get an improved idea, can't we? Let's do it! The mean, median, and mode are the place where we usually start. The mean age is 46.15 years, the median age is 45 years, and the mode is 48 years. All right, the mean and median are pretty close, so we don't have a lot of outliers. As you may recall, the mean is affected by them, while the median is not. Moreover, when the mean is higher than the median, we have a positive or right skew. This is confirmed by our histogram. Now is the time to remind you that skewness shows to which side is the longer tail, and not where the data is concentrated. Now, for the mode, we have 48 years. You can see that from the frequency distribution graph, but not from the histogram. See, the histogram bundles data together, which is good when we want to see the main trend, but some information like the mode in this case is lost. Finally, we should inspect the variability of age. Before we can do so, we have to see if this is sample or population data. The company data is the population of all people who are our customers already. However, our research aims to help the marketing department in identifying future customers. Therefore, our dataset is a sample drawn from all the people who will eventually buy property from our company. Henceforth, we will use sample formulas. Let's compute both the variance and the standard deviation. The former is in squared years and the latter in years. So, I suggest we stick with standard deviation then, shall we? The result is around 13 years. This gives us an additional idea of how dispersed the data is. What inferences can we make from this result? Well, that's the topic of the next section, so we will have to make a halt here. As you may have guessed, our final stop is relationship between variables. Let's see if age determines how expensive of an apartment do customers buy. Maybe younger people have less funds, so they buy cheaper apartments. We don't know. The data will tell us. First things first, let's plot the data. Both variables are numerical, so we'll have to use a scatter plot. Here it is. It seems that it is pretty dispersed and there isn't an obvious trend. Let's confirm this observation by calculating the covariance of the two variables. We get this enormous value that doesn't much. So, it's suitable to standardize it by using the correlation coefficient. The value that we get is minus 0.17. Much better. This correlation is very low. A common practice is to disregard correlations that are below 0.2. All right, so real estate expenditure is not related to age. From a previous lesson, we know that price and size are much more likely to be correlated, right? You have all the tools needed to check this on your own through the exercise after this lesson. So, we've exhausted our statistical knowledge so far. What can we tell the marketing team after this short analysis? Well, we got several insights. First, males are more likely to sign the contract and are potentially a better audience for our ads. However, we don't have any information about their marital status, thus this observation is a bit unclear. Yet, we know that 9% of sales came from corporate clients rather than individuals, which we didn't expect. Second, 68% of our sales in the US come from California, with Nevada, Oregon, Arizona, and Colorado following behind to form 93% of the US customer base. Third, 71% of sales were made with customers aged between 26 and 55 years old, with a mean of 46 years of age and a standard deviation of 13 years. Moreover, the distribution is right-skewed, so we expect younger people to buy more property than older people. Finally, there's no relationship between the age of a given customer and the price they are willing to pay. All right, that was our practical example. We learned a lot about this business, but we were unable to get some truly amazing insights. In the following sections, we will learn about confidence intervals and hypothesis testing. This knowledge will provide us with the tools we need to make predictions about the future and make data-driven decisions.
And one last thing. If you like the course so far, please leave us a review. It helps a lot. Thanks for